Good morning, everyone. I hope all of well, learning more each day. What is semiconductors? What this industry is all about? What are the some concept which I have to learn, right? And this, I think you will find a lot of synergy also of the basics when we go to the which are taught typically in physics, chemistry, materials, different kind of things, right? In your curriculum, if you are below 12th standard or so. So now, in this particular video, we are going to talk about, we have talked about transistor as a switch, right? And we were looking at the system, which is computing and memory, which is typically a CPU. Now, let's look at what is inside a memory, right? And how does this memory work, right? So this memory is what we are going to talk in this video. It's a short video. And it's no surprise that transistor is still playing an important part in this memory. And we'll see how is it in memory. So typically, this is the memory which we are talking, which you will see in your motherboard, somewhere near your processor, right? Which we know as the DDR, right? Or RAM, very nice, right? So that RAM means it's a random access memory, right? And we don't need to really, as of now, go into why it is random, which are different kind of memories, because that is a different video. But as of now, we are going to look inside the memory. What is inside the memory? What is the key component or building block of this memory so that it is able to store my data, it is able to write, it is able to read. So memory has two functions, which are typically you can read, right? Because you want to read what you have written, or you can write what you have written, right? So that is the simple operations which you will see in the memory, right? Reading and writing, right? So now in this particular memory, then the question is, how do you make a memory, right? And what is a very important aspect when we are designing a DDR is to reduce reduce the footprint of your building block, right? So what it means is that if I am going to store a certain number of bits, let's say you are storing 1 GB, right? Which is 10 power 9 byte, right? And byte is like 8 bit. So that means that this needs to be divided in. So if there are, right? So let's say A times, which is A here, A into B should be your 8 into 10 power 9. Because each building block is storing 1 bit, right? So that means whatever is one square here or one building block basically should be so small so that my DDR, or RAM, which I'm want more and more, I can basically fit all of that in whatever area I have, right? So it's a very simple question of that I'm given an area like in Mumbai, and I have to make multiple houses. Obviously, the houses are going to be small because you want to pack more and more houses, right? So that is what we are going, or this is the key constraint which we see in the when we are designing a DDR, right? And that decides the choice of what you would do as a memory, right? So now the question is, ideally, I would want one component to remember, right? So that is what the basically natural thing, to have one component to remember. Now, what is that component? So then the question is that what is that the smallest building block can be, which is very low in footprint, but it does the operation of remembering, and it does the operation of that I can write whatever I want, right? That means I can store whenever I want to store one. or whenever I want to store 0, right? So this is what bits we are talking about, right? Which we want to store on this memory. Now the question is, if I were to use a transistor, simple transistor, which we have seen, is it able to store, right? That is the question you would ask. So then you would see that if I apply a 1 here, right? This is the circuit we were talking about as a switch. And this is the output, right? Where we want to. So let's say, yeah, I mean, that is a different thing that I want to store 0, 1. But the question is, let's say when I apply 1, it gives a 0, right? Here. And now I remove 1, right? So I remove, and this is left without connecting to anything. What would happen to the output, right? So when there is nothing connected, that means if it is connected to 0 or whatever, right? Because that is the state, or it would be in some other voltage. The basic thing which we have to understand is in this circuit that the output would instantly change if there is a change in the input. So that means there is no memory, right, in this circuit. And if you have typically worked or done some of the basic electronic components, such as RLC, which we have talked about, right? So then the question is, where is the memory, right? So if this does not have a memory, where do we have memory? And then we look at our basic elements, which we have studied typically in the first year of electrical, or even in 12th or 10th, whatever. So these are the electronic components we are looking for, right? So as of now, we saw that transistor alone does not have memory, right? So a single transistor, it would not be able to probably give you a memory in the configurations we have talked about, right? Conventionally. So now the idea is that I could do something to the transistor and make it store. That is a different thing, right? So variations can be made to the transistor to make it store. That is a different thing, because that's a technology. I have to develop a new technology, right? But now I'm thinking about that, okay, if I have to store, what are the other components which I have? And from there, you see other components you have studied: your resistor, your inductor, your capacitor, right? These are the basic components which are fundamental to any electronic system you are going to see, right? Which one stores memory out of this? Obviously, resistor has no memory. The only role of resistor is to, and this we will look in detail about these components in some other video. As of now, we see that this inductor and capacitor basically are your storage elements, right? And how does it store? Inductor can store your energy or in magnetic field, right? That is how it stores the information. And this stores in electric field, right? So typically you see your DDR, when it is operating, it is not coming with a magnet, right? So there is nothing where you are manipulating the information by magnets or a magnetic field. We are typically working with voltages, right? That's what is going. So that means a natural choice becomes your capacitor, that I want to store the information in capacitor. So that means if I give charge to the capacitor, right, when it is charged, then this can be named as 1, state 1, where bit is 1. When it is not charged, right, this we can think of as 0, right? That is one of the way you could model or understand the information, that how we can map it to the charge and non-charging of the capacitor. Now the question is, what charges this capacitor, right? Because there should be something, some signal should be coming, and I'm making so many tiles which are like this, right? So if I put just capacitor, something has to drive this capacitor, which makes a decision. So I need something that which capacitor to charge, right? So there is something to make decision device. So let's say you say, okay, there's a control which tells you, okay, this is the capacitor. So there are multiple capacitor, what I'm, right? So there are multiple capacitors, let's say like this, right? So these are capacitor bank, which you see in your DDR, right? But now, because if they are connected, all of them are connected, right, in one row, without a decision device, then if you are passing one here, every capacitor will be charged, right? Because if this, but I want to only write the information, let's say in this capacitor, right? So then what do I need to do is I have to put a decision device with some control knob, right? With some control knob. So these are the control. So let's say this is control 1, this is control 2, right? Control 3, control 4, like that. And that this device has to make a decision, oh, which one is the, which capacitor do I want to write? Because if my control 1, when I say control 1 is high, right, that means I have applied, decision device is like, says that resistance across this device is 0, right? So that means what it is trying to say, okay, yeah, it's like a gate, right? So there are multiple gates you are having, and you are saying, oh, this is where the data can go and write this capacitor. In this, it cannot go. So if control 2 is low, right, the decision device resistance is, you can think of already, right? It has to be very high, because then only it says, oh, the gate is closed for you. Hey, you are coming, I know that you are coming, this information, but you cannot go to this capacitor, right? That is what effectively what you are trying to say, right? So that means now I can see that how, and this information which I am giving, also I can give in different lines, right? So this is the information, which is the input information, which is coming, which we know as typically bit lines in this memory. Okay. And the control lines which are there, which we call as the word lines. Okay. So that is like the basics of the memory, where you are going to see bit lines and word lines. And now there is no surprise. What is this decision device which can do that? And the functionality we need, there is a control knob which basically controls the resistance of that decision device. And this we have seen last time. It's nothing but your transistor, right? Because that is a very nice control terminal, is your gate voltage, which you are applying based on, if you are writing 1, if VG is 0, VG is 0, and capacitor initially, let's say whatever, this VC, we know VC is 0, right? Initial condition of also is 0. So nothing gets written, right? It's 0. If you are reading, it will read 0, simple. But if you write VG equal to 1, then your VC will tends to 1, right? Because then this will give a path. When VG is equal to 1, this guy is going to give a path to charge the capacitor. And that is the basic element or the building block inside this RAM, which you are going to see, which we call as DRAM or dynamic RAM. Right? There are issues, obviously, with this DRAM, and which we are going to talk in some other video, or you can explore by yourself and ask question, what is the problem with this? Oh, very good. I'm going to store charge on the capacitor. Very good, whenever I want. But because these transistors have, even when you apply VG equal to 0, we said current is not 0, right? It's close to 0. So that means there is a finite current, which is what we know as the leakage current, which is flowing through this transistor. And because of that, you are actually going to lose the charge which you have put on the capacitor, right? So that is the leaking of capacitor or information on capacitor. Oh my God, that is a problem on capacitor, right? This is a big problem. And that is why typically to deal with this problem, there is something called, which is used in industry, is called refresh circuitry. That means you are, after some time, you are keep reminding it, oh, don't lose the information. You are 1, stay at 1. You are 0, stay at 0. So that is what is known as the refresh circuit. So with that, I would end here, but I think it gives you a very good idea, probably this video, that what is the building block of this DDR RAMs and everything we are talking about, right? This is just nothing. It's a transistor with a capacitor. That is what is the workhorse of this memory. Thank you.